This is an instructional video on how to perform a concrete slump test. Concrete slump tests were designed to give you a ratio between water and Portland cement and aggregate in a concrete mix. Why that's important: if there's too much water in a mix, the concrete takes an extremely long time to cure, if it cures out at all or hardens at all. The other thing is if there's not enough water, the aggregate will actually, the aggregate in the concrete won't become cohesive and they'll actually fall apart. That's why any structural concrete, whether it be a bridge pillar, or even your concrete floor of your basement, has had a concrete slump test done on it. It ensures the engineer, the designer of the project, and the municipalities that inspect the projects that there is a specific amount of water in the mix, which is directly related to its total strength. So that being said, let's kind of get into the tools to perform the slump test. First and foremost is the slump cone. The slump cone is a 12-inch steel, galvanized steel cone. It's got two foot pedals on it. You can either stand on it while you're performing the test, or in this case we're going to kneel on them. And what that does is, as you fill the concrete cone with concrete, it has a tendency to rise up. So if you have your feet standing on it, or if you're kneeling on it, it keeps the cone in place, and it gives you a valid test specimen. So next is the lifting handles. There's a handle on each side. This allows you obviously to lift the cone off the test specimen once the test is finished. Secondly is a tamping rod. It's usually a 24 or 18-inch steel rod, a 5/8 inch rod with a rounded end on each side. And this rod is used to tamp the material. Once the material is put in the cone, you'll tamp the material with this rod, and what that does is it removes any voids and any inconsistencies in that layer of concrete. Next is a shovel. You can use a multitude of different varieties. It doesn't really matter. All this does is scooping your concrete from your pile here into your cone. Next is just a simple tape measure. Anything will suffice. A standard stick ruler will even work. What this does is when you remove the cone from the test specimen, this actually will measure the amount of slump, or the amount that the concrete has slumped off versus its original height in the cone. And lastly, more of a safety piece of equipment than anything is a pair of gloves. Concrete by design is dehydrated. You add water to rehydrate it when you put it in place, and where concrete gets its strength is it re-dehydrates. The water actually will evaporate out of it because as concrete is made, it actually generates quite a bit of heat, and that'll help evaporate that water out. And it'll essentially do the same thing to your hands. If you get concrete on your bare skin for any length of time, it'll actually suck out the moisture in your skin and can cause what's known as a concrete burn. So kind of nasty business, so we'll use gloves. Okay, let's get started. What you want to do when you're filling your cone is fill it in 3 layers. A third, a third, a third. It doesn't have to be perfect. It's not rocket science. We're just dumping material in the cone kind of in even distributed layers. So the first layer, you're going to want to fill up your first third. Kind of a side note, when you dump the material in your cone, kind of twist your spade around the inside of the cone. It allows for that material to kind of be evenly distributed over the bottom. So we're going to fill our first third here, and like I said, it's just kind of a guess. It doesn't have to be perfect. You're just trying to get it as close to a third as possible. And the reason that you do it in thirds like this is you want to when you're tamping it, which I'll show you here in a second. When you tamp the material, you want to be tamping each individual layer so that you know that every layer got the same amount of compaction. That way you know that your test specimen is valid. Everything's compacted uniformly. So when you're tamping the material, you want to go vertically up and down all the way across the test specimen, and you want to do it 25 times. What this does is it not only compacts the material, but it'll actually allow for an even distribution of the material, because as you compact concrete, it has a tendency to want to level out. So let's go ahead and do that. Now that we've tamped the first layer 25 times, you're going to add a second layer again. Try to fill a third of the cone, or close to it. Now that you've got your second layer installed, you do the same thing, repeated 25 times across the entire cross section. Now that we've got our second layer in, this is the last and final layer. And sometimes it takes 4, depending on the consistency of the concrete. 3 is just a rule of thumb. What's important is you want to get the cone full. So if it takes you 4, or if it takes you 5 because you underestimated the first 2 layers, that's fine. Just a key note here on the last layer, you're going to want to, when you bring your layer of concrete in, you're going to want to overfill the cone, because as you tamp, it's actually compacting that concrete down, and it'll end up below the top of your cone, and you'll have to add another layer. So just a little side note, kind of a trick to the trade. So you want to add your last third of concrete, and as I said, you want to, even if you've got to kind of put your hand around there to get that last little bit of concrete, you want it heaped up above the top of your cone. So as you compact, and you're going to see, as you compact, that concrete's actually going down. Okay, so we've got pretty close here. It's fairly flush to the top of the cone. What you want to do now is you want to take your tamping rod and lay it on the top of your cone and strike the material across. What this does is it kind of gives you a flat surface to measure off of on the top of the cone, and you'll see why here in the next step. So once you strike your material off, set your tamping rod to the side. When you stand up, when you get up off of the cone, it's very important that you lean against the hand pedals with your hands here, and keep constant pressure on the cone. You always want to keep the cone touching the ground until you're absolutely ready to pull the cone off the test specimen. Otherwise you'll have to start all over again, because the concrete cone will come up on you. So you want to lean into it, come up, grab the hand pedals, and what you want to do is you want to pull up at a constant rate until the cone is completely off the specimen. So we're going to go ahead and pull up here. Okay, and what you want to do is you want to flip your cone over, so now you've got the 4-inch side down, and you want to lay your rod across the top of the slump cone. What this does is the bottom of the rod is exactly equal to the height of this cone, which is 12 inches. Now the reason this is called a slump cone is when you pull the rod off, the concrete actually slumps down, hence the word slump test. So what we're measuring for is the distance between the bottom of the rod and the top of the test specimen. In this instance, it is right about 2 inches. So this is what would be called a 2-inch slump. Typically with any kind of structural work, your basements, your sidewalks, anything like that, it's typically between 2 and 4. 2 is a little bit on the stiff side. It's kind of hard to work. 4 is a little bit on the wet side, so somewhere in between 2 and 4. And if it's for an actual designed project where you've got an engineer on the project, they'll tell you what the slump of that concrete has to be. So like I said, this was a brief introduction to how to perform a slump test, and I hope you learned something. Thank you.